Hi there, welcome to the 13th and the final video in the differentiation topic at Higher Maths. We're looking today at optimisation. Okay, so there's going to be 4 different parts to the success criteria for optimisation. Being able to use differentiation to find optimal solution, being able to create a formula for a given context, being able to find the stationary points of a given function, being able to use the nature table to find and improve the nature of the stationary points, and then be able to communicate your answer given in the question. Okay, now optimization is all about finding the optimal thing from what you have. The two examples I like using are if you have an area of cardboard or an area of something, making the box with the biggest volume, making the most of what you have. Okay, so given an area card, how could you turn that into a cuboid that holds a maximum amount of volume? Okay, and if you can model that situation with a formula, essentially you're looking for the maximum turning point. Okay, the maximum stationary point of that formula. The other context I like to use is economics. If you're linking something, if you've got a formula that links cost to profit, you want to maximise the profit. So again, you're looking for a maximum stationary point. And this is where I'm going to teach it or go through it a little bit differently. Okay, optimization always looks the same. You have a part A, which is usually pretty tricky, and a part B, which is always the same. I think you should always go into the exam doing part B first before you even look at part A. Okay, so here's an optimization question, what it looks like. Part A, okay, so part A is always pretty tricky. This one's alright, but part A, you always get given the formula you're aiming for as well, so you can always use it in part B. And I think that's exactly what you should do. Just find the formula and go. You know you're looking for a stationary point question. You're always doing that in optimization. So go and find the stationary point. Okay, so ignoring part A altogether. For part B, the stationary point here occurs when P dash X is equal to 0. Okay, so P dash X, well, firstly, we can't do P dash X yet because there's a fraction. So P of X, first of all, is 2X plus 24X to the power negative 1. P dash X then becomes 2 minus 24X to the power negative 2, and that's going to be equal to 0. Okay, so firstly, to solve this, I would want to rearrange it to get that x squared back in the bottom. 2 minus 24 over x squared is equal to 0. And then I've got a formula, I don't entirely like because there's fractions involved. So I want to multiply to get rid of those fractions. Okay, so I'm just going to come over here. If you multiply everything by x squared, you'll cancel out that fraction. So the 2 will become a 2x squared. The divide by x squared will cancel out, just leave 24. And then 0 times x squared is just 0. And then you're just solving. So 2x squared is 24. X squared is equal to 12, so x is equal to plus or minus root 12 to solve the solution properly. Okay, now briefly dip it into A. With one side of the rectangle is x, so x is a dimension. Okay, and it usually is an optimization question, so just be careful of that. Can it be negative 12 then? So x has to be root 12, as x has to be greater than 0. If it's a dimension, it has to be greater than 0. Okay, now that's you found the value of x. Okay, you just need to do a nature table now to prove that it's a minimum. Okay, so we're looking at coming up to root 12 and coming away from root 12 with my x's. I want to know what the slope is, so I'm using my gradient to do that. Okay, the root 12, if you're looking for values, you know that the square root of 9 is 3. So 3 would be a good one, and the square root of 16 is 4, so 4 would be a good one. Okay, and P dash 3 is 2 minus 24 over 3 squared. Okay, which is minus 2/3. Okay, so there 3 is minus 2/3, so that's a negative. We know it's 0 at 12, so it's straight across. And then P dash 4 is 2 minus 24 over 4 squared, which is 16, which makes that 3 over 2. So 2 take away 3 over 2 is a half, which makes that positive. So perimeter, sorry, terrible, perimeter minimized when x is equal to root 12. Okay, using your nature table to prove it. Okay, now that will always get you 5 marks. Okay, this question here would actually be a 6th mark because it was asking for the dimensions. Okay, I'm going to return to that later on because we do need to have part A for that 6 mark. But either way, you're looking at one of the trickier questions in the exam and you're knocking out 5 marks without even thinking, which is great. Okay, so now we need to look at part A. Okay, the area of a rectangle is 12. If one side of the rectangle is x, show that the perimeter of the rectangle is given by px equals 2x plus 24 over x. The optimisation is quite tricky because there's lots of different ways of asking for it, lots of different contexts. No two are ever really the same. We can generally get a point where we're looking at two different geometrical things. Most of them are to do with that. Okay, so in this one we're looking for perimeter. Okay, so I'm looking for something to do with perimeter, and I'm talking about a rectangle. It tells me I'm talking about a rectangle, one side x. Okay, so I've got a rectangle, and I know that one side of that rectangle is going to be x. Let's just call the other one y just now. So I know how to calculate perimeter, I've known that for ages. So you guys, the perimeter of that rectangle is 2x's add 2y's. Now that is a formula for perimeter. The problem we have is perimeter here is only in terms of x. It's a function of x. There is no y's kicking about. And that's where they give you another value. Okay, so here they're telling you that the area of the rectangle is 12. Again, we know the area is length times breadth. Okay, we know the answer is 12. Here the length and breadth is x and y. So 12 is equal to x times y. And that gives us an opportunity to change the subject and get a value or something, an expression to sub in instead of y, so I'm only dealing with x's. So y is equal to 12 divided by x. So that means I can go back to my perimeter, and if I just look at it as a function of x, that's 2x plus 2 times 12 over x. Okay, and doing that multiplication, it's 2x plus 24 over x. Job done. Okay, now that's the basic structure for most optimization questions stays the same. You've got two different things. One, you're looking for perimeter or you're looking for surface area, and it gives you information about area or volume. Okay, but you've got to create the situation, look at the situation, find out exactly what's going on, and then use the other thing to get an expression to sub out another variable. Okay, but that does become trickier and trickier as you get more and more examples. There is lots of different things going on. I think you should be making sure part B is perfect. Okay, so go in, get that done, get that fixed, and then go back and look at part A afterwards. Okay, now lastly, I'm just going to go back a couple of slides because part B asked you not just for x but for the dimensions of the rectangle. So here we knew that x was root 12. Okay, but we needed to find other dimension as well. So we need to find y, and here is a formula. Y is equal to 12 over x. So if we go back to part B there, in that rectangle where it was x and y, x is root 12, y is equal to 12 divided by root 12. Okay, which is just root 12 as well. Okay, so that's the dimensions of your rectangle, and that you can go back and get the 6th mark. Not always available, depends on how they ask the question, but it's there for you. Okay, so here's a past paper question. Okay, talking about an open water tank, bit trickier. To be honest, I don't really care right now. What I want you guys to do is go in, look at the formula you're given, and find the minimum surface area. Find that stationary point from part B. Okay, so part B, there's my formula. I know, right, well, firstly, I need to rearrange that to differentiate, so it's going to be x squared plus 432,000 x to the power negative 1. My stationary points occur at a dash x equals 0. So a dash x is 2x minus 432,000 x to the power negative 2 equals 0. Rearrange to get rid of that negative power. As soon as I'm going to work with it, I want it to be as nice as possible. And then I don't like fractions, so I'm going to times everything by x squared. So that's going to become x cubed minus 432,000 equals 0. Okay, add 432,000, divided by 2 gives you 216, and cube root it gives you x as 60. Okay, let's look at the nature table just on this same slide. So my nature table, as my x's approach 60 and come away from 60, let's call it 59 and 61. I want to know what's happening with the slope, so I am going to go to my differential. Okay, so a dash 59 is 259's take away 432,000 over 59, and doing the same with 61. Can't do these ones in my head, so I'm going to start the video and it's 432,000 over 61 and get values for them. Give me a wee second. And as if by magic, there's your answers. I missed the squared out when I was talking before, by the way. Okay, so when it's 59, it's minus 6.1, which means it's going down. We know at 60 it's a station point, so it's 0, and at 61 it's 5.9, so it's going up the way. Okay, so the minimum surface area. Okay, this is terrible. I'm just going to go at the top. So minimum surface area when x is equal to 60. Okay, and that's all 5 marks there. Job done. 5 out of 8. Tricky question. Not a problem. Okay, now we look at part A. Okay, so show that the surface area to be aligned A is given by that formula. Okay, so we're working towards that area, and it's a surface area. So just looking at the area of the surfaces. Okay, now the surface area of that triangular prism involves 2 triangles, one here, one at the back, and then 2 rectangles. Okay, now you know the area of a triangle is half length times breadth. So here, x times x, so it's going to be half x squared. Then you've got 2 of them, so half x squared plus half x squared is just x squared. Then you've got 2 rectangles, length x, breadth L, so it's going to be XL, there's 2 of them, so it's 2XL. Okay, so that's the surface area formula you're trying to get to. Okay, but you only want it in terms of X, so we need to get something else to give you a value for L. Now if we go back, you can see it also tells us up here the capacity is 108 litres. Okay, and sorry for jumping about a bit, it's just a bit awkward. Okay, so the capacity, the volume is 108 litres. Okay, now everything else is in centimetres, so this has to be in centimetres cubed, and we know that centimetres cubed is the same as a millilitre, so that's 108,000 centimetres cubed. Okay, now the volume of that prism is the area of the cross section times the length there. Okay, so the volume is half x squared times the length, and we know that's 108,000. Times by 2 to get rid of the half makes that 216, and then divide by x squared means that L is 216,000 divided by x squared. So then going back to this surface area, the area only as a function of x is x squared plus 2x times 216,000 over x squared. Okay, which tidies up x squared. 2 times 216,000, or 2x times 216,000 is 432,000x, but then because there's an x squared on the bottom, that x will cancel out one of those and just leave you with 432,000 over x. Okay, so that's you showing it. Okay, again, we've got some values for volume, so we can use that to give us an expression to sub out L and just has a function in terms of x. Okay, there's lots of different types of optimization. I would encourage you to go away and just practice them. Okay, and every time go in, do part B, and then have a look at part A. Even if in your exam it's the last thing you do after you've got the rest of your marks, have a battle with part A just to kind of finish off. Okay, so looking at the success criteria, okay, so this here, part A, that could have went at the end, because that's where you're going to do it, but being able to create a formula from given contexts. Being able to find the station points of a given function, being able to use the nature table to find prove nature of station points, and then be able to communicate the answer given in the question. Okay, so are you finding x? Are you finding the dimensions? Is it you're actually finding? You might be asked to find what the actual surface area is that's minimised, something along those lines. Okay, apologies for all into this video, but thanks. Cheers. Bye. Bye.